What a great day to look at systems of equations word problems. I bet there's nothing else you would rather be doing right now. So let's not fluff it. Let's just get after it, talk systems word problems, and blow it up. We're going to commence with systems word problems dealing with a tangible item, something that you can touch. Although, as we get further on in um, our lifetimes, at least in my lifetime, being born in 1982. I was younger. Credit cards were not a big thing. Debit cards, I don't think were really invented. Cash was used a lot, but the older I get, the less and less cash coins are used. So this may be coming from an older person standpoint. But a tangible item, something we can touch, is we are going to discuss coin problems today, where we are going to be looking at situations where I have two different types of coins that have a certain value, and I'm going to try to determine how many of each type of coins I have. So before we get into the meat and potatoes, we have two examples. We'll talk about how we're going to set up the system of two equations with the two variables. Let's just do a quick little review here of the different types of coin types you will see. We'll use P, or you can use any variable you want, but I'm going to use the letter P for a penny. It has a value of 1. With coins, it is important that we use cents for units. If we were going to use dollars, we'd have to use decimal values, like a penny is $0.01. I think it's just easier to use whole numbers versus decimals. That's just me. We're going to use cents for units. Why? Because it makes sense. There we go. Cents and cents. Cents makes sense. Amen. I'm going to use the letter N to represent a nickel, 5-cent value. D for dime, 10 cents there. Q for quarter, 25 cents. H for a $half, also known as a 50-cent piece. I'm going to use N for a dollar. I'm not. Why would you use N? Well, D we've already used, and a dollar you might think of $1, the little N sound there, the second letter of one. So I used N for a dollar. You can use a different letter if you would like, but that's just what I'm going to use. So with our systems, we are again going to have two equations with two different types of coins. So the two equations that we are going to look to set up today are the following. First is what we call the quantity equation. We want to know how many coins are there. And there's two types of quantity equations. You may be given the total number of coins, which we'll see in one of the examples, or you may have a comparison of the two different coin types. They may be compared one versus the other. And how do you know? Well, a lot of times you'll read and it'll say there were a total of 90 coins. But the key word here to know if you have keywords, I should say, to know if you have a comparison equation is the word more or the word less or greater, fewer. So you might have an example where I have 15 more quarters than nickels. So that would be a comparison equation. We'll talk about how to set those up here momentarily. And then finally, the value equation. The value equation will be the steady, the same setup for each of your system's word problem types. So the value won't depend whether or not it's a total or a comparison quantity equation setup. The value will be the same each and every time. So let's take a look here. I've got the two examples that we are going to go through. Example 1, we've got anchovy had 60 nickels and dimes whose value was $5. How many of each type did she have? So first we're going to look and say our quantity. Are we given the total number of coins, or are we comparing, in this case, the nickels and dimes together? Well, it says she has 60 nickels and dimes, so it's a grand total of 60. So I'm going to write an equation that says I have some nickels, I have some dimes, I put them together, and there's 60 total. So that setup would be N nickels plus D dimes equals 60 total. Now, the value equation. I want to know how much are the coins worth. And the value, again, we are going to use cents for our units. So a nickel is 5 cents in value, so I'm going to say 5 cents for every nickel plus 10 cents for every dime needs to add up to a total of $5. If you put 5 here, this will not work. Since you have 5 cents, 10 cents, you need to write your second equation in cents. It needs to make sense. So $5, be careful, is 500 cents. So now you are going to use either substitution or elimination to solve for n and d. When I have my like terms in columns, I think it's easier to use elimination. So I'll get opposites by multiplying the top equation by -5. Why I did that is if I have -5n and +5n, they will eliminate, make 0. So here's my new first equation. -5n minus 5d will equal -5 times 60, -300. Since I have opposites, I can add the equations. The n's cancel out, make 0. My d's, 10 and -5, make 5d, will equal 500 and -300 is 200. Divide both sides by 5. And I'm going to have d, my number of dimes, is 40. Well, you can probably use mental math. If you have 40 dimes and 60 total coins, mental math would say, oh, it's 20. If you're not sure, nickels plus dimes is 40 has to equal 60. Subtract 40, and nickels would be 20. So we can always double check. 20 and 40 make 60 total coins. 20 nickels, 20 times 5 is 100 cents, $1. 40 dimes, 40 times 10 is $4, 400 cents. $4, $1 makes $5, 500 cents. So 40 nickels, 40 dimes and 20 nickels. There we have it. Isn't that great? So total, pretty straightforward. I think with total systems, elimination is the easiest method to use. All right, let's take a look at a comparison. These are a little more challenging, not difficult by any means, but with comparisons, we are going to have to use, I call them bar graphs or little visuals to help us determine which one has more or less coins in quantity. So example 2, it says the value of the quarters and nickels was $11.70. If there were 30 more, see that 4-letter M word after 30, more, 30 more quarters than nickels, how many coins of each type did Misty Meaner have? She's a smooth criminal, old Misty Meaner. So here's how a comparison works. I like to draw little comparison bars, I call them. So I want to know which coin do I have more of? Well, I'm told there are 30 more quarters than nickels. So if my nickels are less than the quarters, I want to know how could I get these two bars to be equal in height, have the same quantity? Well, if I have 30 more quarters, I would need to add 30 to my nickels, so I would have the same number of quarters and nickels. For instance, if I had 70 quarters and 40 nickels, 30 more quarters than nickels, I would need to add 30 to 40 to make 70. So in general, I always need to add 30 to my number of nickels to equal the number of quarters. So that can be a little challenging. So work with me. Let me know if you have questions on that comparison setup ever. We said the value equation, that one stays the same. The setup is exactly the same every single time. I usually start with my smallest coin value to write first. So between quarters and nickels, a nickel has a smaller value than a quarter. So 5 cents per nickel plus 25 cents per quarter is going to equal a grand total of $11.70. So if you write down 11.70, remember, we always have to use cents for our units. So to make dollars into cents, there are 100 cents in a dollar. So this will equal 1,170 total cents. So when I have a comparison equation, one of my variables is going to be isolated. It's going to be that single and positive that we talked about when we discussed substitution. So when I have a comparison, I like to use substitution. So in this case, I'm going to take n plus 30, pick it up, and put it in place of q in equation 2. So my new equation, 5n plus 25 times q, which is equal to n plus 30, will equal 1,170. I'll distribute 5n plus 25n plus 25 times 30, I believe, is 750, will equal 1170. 5n and 25n, like terms, 30n plus 750 will equal 1170. Subtract 750 from both sides, and I'll have 30n equals, I believe, 420. Divide both sides by 30. And n, my number of nickels, is going to be 14. So I have 14 nickels. My quarters then are going to be 30 more than the nickel. So if I plug in 14 for n, my q quarters will be 14 plus 30. 14 plus 30 is 44. We can check it. Is quarters 44 equal to 14 plus 30? Good. 5 cents for a nickel. 5 times 14 is 70. So we got 70 cents on nickels. 44 quarters. Well, there's 4 quarters in a dollar. So 44 would be $11. So 70 and 11 makes 1170. So we're good. So those are your two types: comparison, the type we just finished with, and then your total. Again, you can solve any method you'd like. You can always use elimination substitution, but to wrap it up, I would use elimination when I have a total quantity, because you have your like terms in columns, and I would use substitution with a comparison, because you will have a single and positive, one variable equals everything else. Thanks for your time. Have a great day.